Hey, Chris, what are you doing here? Thought you said you were going fishing.
That's a long story, Tech. I'll tell you about it sometime. But in the meantime, I thought I'd bring Tom up to date on some new steering developments. Here comes Tom now.
Hiya, Tech. Glad to see you back. Gonna give Chris a hand on this steering session?
Bet your life. And it's going to be interesting, too.
I thought we'd talk first about some manual steering gear improvements. Then we'll cover some power steering features, which are also new. For example, in the manual steering setup, there's a new flexible disc coupling used between the worm shaft and the steering tube. These parts replace the single tube formerly used.
What's the reason for that change?
Well, there are several reasons for the change, Tom. First, it's easier to align this gear than the former type. Also, it reduces the transmission of road shock and noises in the car, and it makes the service job easier.
Sounds great, Chris. Tell me more about it.
The lower hub of the coupling is attached to the steering gear worm shaft by a serrated connection and clamp bolt. This shaft has a master serration, which is lined up with an index mark on the outside of the hub. The upper coupling hub is integral with the steering tube. The flexible disc is installed between the two hubs. This arrangement simplifies alignment between the worm shaft and tube.
I can see that, but what's the alignment procedure?
Well, you won't have to bother with the D-bar and wedge to align the gear. They've been eliminated. Instead, the face of the housing is machined flat, so it rests flush against the frame.
Say, that ought to cut down the alignment time a lot.
Yes, it should. And when you install the chuck, you immediately tighten the 3 attaching bolt nuts evenly to 50 foot-pounds torque. Then, be sure the jacket lower clamp bolt nuts and the column bracket stud nuts are loose enough to permit movement of the jacket. Next, tighten the instrument panel steering gear bracket bolts finger tight. Then center the lower end of the jacket around the steering tube. At the same time, examine the disc to be sure there is no deflection or distortion. If there is, the jacket should be moved up or down to correct the condition. Then, tighten the column bracket stud nuts to 100 inch-pounds. Next, tighten the jacket clamp bolt nut to 200 inch-pounds. Then, torque the instrument panel bracket bolt nuts to 15 foot-pounds. Finally, re-examine the disc to be sure there is no deflection.
And that, Tom, is the story on the gear alignment. Not bad, eh?
Very good, I'd say, Tech. What else is new about this gear?
Well, there's a new rubber lip-type seal in the lower end of the jacket that seals around the tube.
And remember this, Tom. Every 5,000 miles, or more often if a squeak develops in this area, apply a coating of wheel-bearing lubricant to the lip of the seal.
I read you loud and clear, Tech.
The horn wire that formerly came out of the lower end of the gear now leaves the column jacket with the directional indicator wires. The horn ground is attached to the underside of the coupling by 2 bolts to complete the ground circuit. Also, on cars with manual transmission, there's a new stamped jacket clamp at the lower end of the column. This clamp offsets the lower end of the gear shift tube from the jacket toward the engine.
Chris, why is that offset needed?
Well, it's needed to provide clearance between the clamp and clutch linkage torque shaft, so there's no possibility of interference between these parts. Here's another interference item you might watch for on new car preparation. See that the speedometer cable and the gear shift control cable on automatic transmission-equipped cars are kept clear of the coupling. On some early models, without a supporting clip, the cables are routed across the coupling, and if they don't have enough clearance, they could be damaged by the coupling. On later models with the clip, be sure the end of the clip is bent over to hold the cables in place.
You can make a clip that'll do the job. Just be sure to wrap it with tape so it won't chafe the cables.
Okay, Tech, I'll remember.
Now, there are a couple of other items I'd like to talk about on this manual steering gear before we leave it. They have to do with reports of hard steering and wander.
Good thing you mentioned that, Chris. I was just going to ask you about it.
Well, I'm glad I beat you to it, Tech. Well, Tom, you might get an occasional case of hard steering or wander on cars with manual steering, and on cars with power steering, you may get reports of poor returnability.
What'll I look for?
Well, in some cases, you'll find the trouble in the column jacket upper bearing. You see, if this bearing is damaged, steering will not be as smooth as it should be.
What causes that?
It's like this, Tom. The bearing seats on 3 supporting lugs in the upper end of the jacket. It is then held in place by crimping 3 tabs on the upper edge of the jacket. Sometimes the bearing is not seated properly before crimping the tabs, and excess pressure may damage the bearing or cause it to be misaligned. In other cases, the end of the jacket may be out of round, and when the bearing is pressed in place, the uneven pressure has a tendency to develop roughness in the bearing.
What's the fix?
Well, the column jacket has to come off so a new bearing can be installed. Be careful you don't break off the tabs when you bend them back to remove the old bearing. Before installing the new bearing, start it squarely into the jacket and carefully check the shape of the jacket to be sure it's round. If the jacket is out of round and cannot be trued up, it will have to be replaced. When you install the bearing, start it with the radius on the inside diameter facing downward. Then press the bearing squarely into place.
And be sure you put that new washer on top of the bearing before you crimp the tabs.
Bend those tabs down to an angle of about 45 degrees instead of 90 degrees, so the bearing will turn freely. If the trouble is not at the upper bearing, you'd suspect it to be in the gear. On some early models, it could be due to the adjusting screw snap ring coming out of its groove in the gear shaft. To verify this, remove the 4 housing cover screws. If the cover can be lifted off with the adjusting screw and lock nut intact, the snap ring is out of its groove in the gear shaft. In that case, the snap ring groove is too shallow, and the chuck should be removed from the car and placed on the bench for disassembly and repairs.
I suppose in that case I'd have to replace the gear shaft, huh?
You're supposing right, Tom. In addition, you might also have to replace the upper and lower housing bearings if they're damaged, and of course use a new snap ring and oil seal. If the cover is bent, replace it too. After you build up the unit, install it. Then align it the way I just showed you.
I get it, Chris. I'll have it done in just a few minutes.
While you fellers are doing that, I'll get someone to turn the record.
Now that we've covered the manual steering gear, let's talk about the new, larger slipper-type power steering pump with the new reaction mounting bracket.
Good idea, Chris. Tom can use that information.
Go ahead, Chris. I'm all eyes and ears.
Well, Tom, this new pump is now used on all V8 engines with displacement of 361 cubic inches or more. It has a new automatic belt tension controlling feature called Load Reaction Belt Tensioner.
You mean we don't have to adjust the pump belt anymore?
Now, wait a minute, Tom. Don't jump to conclusions. Why don't you just listen to Chris as he explains this to you? Go ahead, Chris.
Well, this new mounting is a combination pump mounting bracket and adjustment bracket. These brackets and a pivot bolt operate together to provide a flexible pivot-type mounting. Its purpose is to take advantage of the torque reaction of the pump to automatically vary the belt tension when higher pump loads are imposed, such as when parking the car at the curb. In other words, as the pump load increases, the belt tension is increased to prevent belt slippage. You see, Tom, most belt slippage and wear takes place when the pump is under heavy load. But with this new automatic tension take-up, belt life is increased and fewer belt adjustments have to be made.
Sounds good to me, but maybe if you explain how it works, I'll understand it better.
Okay, Tom. We'll start from the beginning. For normal operation, the belt should operate with its basic adjustment, that is, with 45 foot-pounds tension.
Is there a new procedure for that?
Yes, there is, Tom. To adjust the belt, we use this new belt tension adapter tool and a torque wrench.
New tool, huh? How's it used?
Well, first you loosen the 2 adjustment bracket to engine mounting bolt nuts. Then, with the tool mounted on the drive of the torque wrench, you fit the tool over the edge of the pump mounting bracket as close as possible to the outer edge of the bracket. Next, tighten the belt until you get a reading of 45 foot-pounds on the torque wrench. Hold that tension while you tighten the bracket mounting bolt nuts enough to hold the adjustment. Then, use a torque wrench to tighten the nuts to 30 foot-pounds torque. You got that?
Yeah. Is that all there's to it?
Yes, Tom, but bear this in mind. When the belt is properly adjusted and normal pump pressures are developed, the pump mounting bracket will be resting against the rubber stop in the adjustment bracket. Now, you might occasionally come across a case where the belt tension was adjusted too loosely, or where there is a squealing noise from a belt that is worn. Also, you may have a case of a slight knocking noise caused by the bracket vibrating against the rubber stop.
In that case, I'd readjust the belt with the tension tool and torque wrench, right?
Right you are, Tom. But if you can't get a good adjustment, or the pump still vibrates, replace the belt.
That's good advice, Tech. Tom's learning fast.
That automatic belt tensioner is a good deal. Is there anything new on the pump itself?
Yes, Tom, there is. Basically, the pump is the same slipper design as before. However, the diameter of the reservoir and the mounting flange are increased from 4 5/8 to 5 1/8 inches. In addition, the pump shaft and seal diameters have been increased. As a result, this larger pump has a 25% greater capacity than the former one. That lets the pump move a larger volume of fluid at the same pump speed, so both pump and belt life are lengthened. In addition to having a greater capacity, this new pump has some design changes you ought to know about. For example, the flow control valve doesn't have orifices like the former valve did. Instead, it is a new spring-loaded solid flow control valve. There is a separate orifice sleeve pressed in the pump outlet passage in the pump body. 2 orifices in the sleeve line up with the flow of fluid from the flow control valve. In addition, there is a new ball-type pressure relief valve, and it is serviced as an assembly. The relief valve comes in 3 different capacities, and they are marked for easy identification.
Chris, before you tell Tom about those markings on the relief valves, why don't you tell him about the use of this new pump on truck models?
That's a good idea, Tech. I'll do that. This new pump, with some internal differences in flow control and pressure relief characteristics, is used on V8 truck models, but with the conventional mounting brackets.
What are the internal differences, Chris?
For one thing, the 2 flow control orifices in the sleeve are larger to allow a greater volume of fluid to flow through the system. The truck pump flow is 3 3/4 gallons per minute against 2 gallons per minute for passenger car pumps. The relief valve is the same type, but also comes with different capacities. Here's the lineup. Truck models, series 100 through 600, use the 900 to 1000 psi valve. It's identified with a small square tool mark on the hexagon section. All passenger car models using this larger pump, except Imperial, and truck models, series 700 through 1000, use a 1000 to 1100 psi valve, marked with a small triangle. The third valve is used only on Imperial models. It has an 1150 to 1300 psi capacity and is identified with a small round mark.
Don't look so worried, Tom. Those specs are listed in the reference book in case you forget them.
Why, I'm sure glad of that. Anything else new on this pump?
Yes, Tom, one very important thing. The same service replacement pump package will fit on both passenger car and truck models. However, this service package consists of only the partial pump assembly with seals. You transfer the reservoir, pulley, and relief valve assembly from the used pump to the new pump, if they're serviceable. If not, replace them with new parts.
Say, how can you use the same pump in cars and trucks when the orifice sleeve is different?
Well, that's just what I was going to tell you about. The outlet passage bore in this service pump is machined differently than in the production pump. The counter bore is deeper in the passage. In addition, the orifice sleeve has 2 sets of different size orifices. The sleeve is positioned with the small or lower set of orifices in line with the flow of fluid from the rotor for use in passenger cars. Then, if you want to install the pump on a truck, you merely use a length of 1/4 inch round steel rod and drive the sleeve down to the counter bore. This lines up the larger orifices with the flow of fluid.
Tom, be sure there's a slight chamfer on the end of the rod so you don't damage the relief orifice in the end of the sleeve.
I'll be sure to remember that, Tech. Anything else I should know about service on this pump?
Yeah, Tom. Because of the larger diameter shaft and seal, new service tools are required. There's also a change in the hub puller. You'll find that information in the reference book. Well, that just about winds up our story on the power steering pump and new mounting. Just be sure you remember to use the proper relief valve in the replacement pump. Refer to the chart in the reference book if you've forgotten how the valves are marked.
You see, Tom, if you get the wrong valve in there, you won't get the proper pressure readings for the car you're working on.
You can count on me to install the correct valve, Tech.
And one last thing. When you install the replacement pump on a truck, be sure the orifice sleeve is driven down into the proper position. Otherwise, you won't have the proper volume of flow.
I'm sure Tom and all the other technicians are now up to date on steering information. I'll run along now, but I'll be seeing you next month. We'll have another good subject to discuss then. So long, fellas.
So long,
So long,
Tech.
Tech.